Hey everyone, I'm Ms. Mulkowski, the mathematician, and today we're going to talk about 45, 45, 90 triangles, special right triangles. And in the last video, we spoke about if you are given the length of one of the legs, find the length of the hypotenuse. So in this video, we are going to do the opposite. So we're going to be given the length of the hypotenuse and we want to find the length of the leg. Remember, and it'll be the same as the other leg since it's isosceles. All right, so let's get started. In this video, I'm going to show you 3 ways to do it. You have to pick the way that's best for you, and you're also going to realize sometimes, depending on what value you're given for the hypotenuse, certain ways are easier than others, less cumbersome than others. And remember, the fewer steps we can take to get to the answer, the better it is because we're less likely to make a mistake, right? Every step we take is a chance to make some sort of silly mistake. All right, so let's start with way 1. So in way 1, I'll make that a capital W. Way 1, we are going to use the side ratios. Okay? So you probably remember from class when you were taught that in a 45, 45, 90, if the measures of the legs are X, so remember this leg is going to be X, so remember this is, I'll just show you that that's the 45, 45, 90. Okay? So each leg measures X, then that means the hypotenuse measures X root 2. Okay, so if we are given, if we use this, because it shows us the ratio of the sides, x to x root 2, we can use that to find the measure of the leg if we're given the hypotenuse. So right away, you can see that the hypotenuse is in the form x root 2, right? There's a number out front times root 2. So it's actually going to be super easy. If the hypotenuse is 5 root 2, then that means the length of the leg is going to just be 5 because it's always leg and then leg times root 2 for hypotenuse. Okay, so it's in that form. This is super awesome. It's in the form x root 2. Okay, so 5 root 2 equals x root 2. Okay, because you can see 5 root 2 equals x root 2. So then all we're going to do is divide both sides by root 2. Okay, boom, boom, and we're left with 5 equals x, and I like to write it around the other way, x equals 5, okay? Super duper easy, and again, you didn't even have to write that out if you didn't want to. I mean, it's good to practice because when things get more complex, you're gonna wanna write it out, okay? But we just say, oh, it's something root 2, so the length of the leg is something, the something that's in front, whatever's in front. As long as this is root 2, whatever's in front is going to be the measure of the leg, all right? Now, I'm doing 2 examples because one of them is going to have it in the form something root 2 and one of it's just going to have it like, 12, okay? So let's do that again, the same concept. So this is going to be a little bit harder because it's not in the form x root 2, so it won't be as simple as, for example, if this were 7 root 2, the length of the leg would be 7. If it were 12 root 2, the length of the leg would be 12, okay? So what we're going to do in this case is kind of the longer way, which is the way I just showed you at the tail end of that, which is to say that this is 12. So then that means that 12 equals x root 2. Because remember, we're solving for x. The length of the hypotenuse is x root 2. The length of the leg is x. Okay, so we just solve for x. So we divide both sides by root 2. Divide both sides by root 2. So that'll go away. And we're left with 12 over root 2 equals x. Okay, now we want to rationalize. We don't want any radicals in the denominator. So what we're going to do to rationalize is to multiply both sides by root 2, or sorry, not multiply both sides by root 2. What am I saying? I'm on autopilot here. You're going to multiply by root 2 over root 2, okay, which not is essentially 1, it is 1, okay? And then we end up in our numerator with 12 times root 2, so that'll be 12 root 2 over root 2 times root 2 is 2. If you needed that middle step, root 2 times root 2 is root 4, and then the square root of 4 is 2, so that would be the middle step, okay? Perfect, and then we just need to simplify, so we can 12 root 2 over 2, we can divide out a 2, so we are left with 6 root 2 equals x, and if we want to write it nice and big, I can kind of come over here and just write it x equals 6 root 2. Okay, perfect. So in this case, we had to do a little bit more work, okay, because we ended up with a radical in the denominator. So we had to multiply by root 2 over root 2 to get rid of that. It became root 4, which is 2, and then we simplify because 12 over 2 is 6. So it becomes 6 root 2. So there you go, that's way 1. So now we're going to take a look at way 2. And for way 2, we're going to use what I call the tricks, okay? Now, I have a video devoted to these tricks, and if you click right up there, you can watch that video, all right? So I'm just going to apply the specific trick of moving from hypotenuse to leg in a 45, 45, 90, okay? And that is what you do to move from hypotenuse to leg is you divide by 2 and then you multiply by root 2, okay? Again, you divide by 2 and you multiply by root 2. So we are going to take 5 root 2, okay? And so we're going to do exactly what I said. So we're going to divide by 2, and then we are going to multiply by root 2, okay? So then what we end up with here is going to be 5, and then root 2 times root 2 is root 4. I am going to show the middle step here just so we don't have confusion, okay? And we end up with 5 root 4 over 2. Well, the square root of 4 is just 2, so it becomes 5 times 2 over 2, okay? Now, obviously, we have a 2 in the numerator and denominator, so those divide out, and so we are left with 5. So that is going to be the length of our leg. It's just going to be 5, okay? Now, you just watched way 1. Is way 2 a little bit more complex? Yeah, it's more complex, it's more cumbersome. There's a greater chance you can make an error because you're doing a lot of calculations. So if it's ever in the form x root 2, I would not use the trick for that because it's going to take you a lot longer, okay? But I wanted you to see because it's important. All right, so now let's apply it to this other example, okay, where we know the hypotenuse is 12. So remember, when we are moving to the leg, what we want to do to the hypotenuse is we want to divide it by 2, and we want to multiply, and then we want to multiply it by root 2. Okay, so we're going to take 12, we're going to divide it by 2, and then we're going to multiply it by root 2. Okay, so we have 12. We are going to divide it by 2, and then we are going to multiply it by root 2. Okay, divided by 2, multiplied by root 2. Does that look familiar? If you think back to way 1, this was like the second to last step, okay, of that way. So look at this, way 2, this is so much faster. We just cut out everything, okay? So 12 divided by 2 is going to be 6, and then times root 2 is just 6 root 2, and that is the length of the leg, okay? So as you can see, the way 2 for the second one was a lot faster. The only caveat with this is you have to remember it's divide by 2, multiply by root 2. So what if you forget? What if you did divide by 3, multiply by root 2 or something like that? So that is the only dangerous part with this, okay, is that you are memorizing, which can be a problem because if you memorize incorrectly, then you're going to get the whole problem wrong. So that is one reason to maybe stick with way 1. But there's no harm if you have a lot of time and you do it way 2 because, you know what I mean, you want to make sure you at least get an answer down. And then if you still have time, go back and check it doing way 1, okay? So yeah, so that is super duper simple. So we just take, in both cases, we take the hypotenuse, we divide by 2, we multiply by root 2 to get the length of our leg. All right, so now we're going to try way 3, okay? So way 3 is using Pythag, all right? So this is great because this is your foolproof, like, oh my gosh, I forget everything. I don't remember the ratio of the sides. How, like, was it x root 3 or something? There's something with a root 3 because remember, 30, 60, 90 has a root 3. This is the most common thing I would see with students on tests was that they would forget the ratio. Okay, so if you forget, you say, have no fear, Pythag, that's something I learned in middle school. I know I can do this. I remember Pythag, you know, a squared plus b squared equals c squared. I mean, I still ask people my age Pythag and they can still rattle it off. So I feel like for some reason that stays with everybody. So it's good, you can use it, okay? So again, remember the cool thing about 45, 45, 90 triangles is that they're isosceles. So you know the leg is x, that's what you're trying to solve for. So you can just call the other leg x because they have the same length, they have the same measure, okay? So it makes it easy, all right? So then what we're gonna do in this case is we're gonna say, oh, well, I remember Pythag, this is great. So I can just say, trying to solve for x, so x squared plus x squared equals 5 root 2 squared, okay? So x squared plus x squared, that's going to be 2x squared. And then 5 root 2 squared, the quantity 5 root 2 squared. So what you're going to do is remember you have to distribute that squared to both, okay? So that's going to equal 25, and then root 2 squared is just 2. Okay, now I know that that's 50, but we've always talked about how I do things differently. I like to leave stuff. I always say don't waste your time multiplying stuff through until maybe you've already divided if you're going to have to, because it'll make things easier. So watch what I do here. I just divide both sides by 2, because remember, I'm trying to isolate x. That's the whole point. When I divide this side by 2, I see a 2 in the numerator, 2 in the denominator, and I know they're just going to divide out as well. So I end up with x squared equals 25. Okay, again, if you wrote that as 50 and then you divided it by 2 and you'd still get 25, and that's fantastic. I'm not trying to make you do it my way. It's just that's a very important thing to kind of think about, because when I do higher level math problems that involve, bigger numbers, I tend to not make the big numbers. I tend to just write, the factors, because it's easier to deal with. Okay, so now for solving for x, we have x squared equals 25. So now we're just going to square root both sides, and we end up with x equals 5. Perfect. And that's what it was. We remember from before, that's what it was. So there you go. If you forget things and you're like, well, I can't remember if it was x root 2, x root 3, x root 5, 1/2 x root 2. I've seen some people do that before. You can now say, well, I can just use Pythag. It's super duper easy. So we're going to try it with this other one as well, okay? With the 12. Whoops. Okay. So let's do the same thing. So we're saying what's the measure of the leg, and we know the other leg will also be x, so we're just going to use Pythag. So it becomes x squared plus x squared equals 12 squared. Okay, so that's going to be 2x squared equals 12 squared is 144. Okay. Then you are going to divide both sides by 2, because we're trying to isolate it. Divide both sides by 2, divide both sides by 2. So you end up with x squared equals 144 divided by 2 is going to be 72. Now, just an aside quickly that I'm going to erase. Remember how I said sometimes I like to write it out? So if I hadn't written it as 144, if I had chosen to write it as 12 times 12, okay, I could then write that as 12 times 4 times 3, and I could then write that as 12 times 2 times 2 times 3, okay, which then when I divided by 2, one of those would have gone away, okay. Now, some people may argue, well, then I'm doing 12 times 6, which is just as hard for me as doing 144 divided by 2, and that's fine. You could say, okay, well, 12 times 2 times 3, so you could either say, well, I'm going to do 12 times 3, which is going to be 36, and then double that to 72, or you can do 24 times 3, whatever. The point is that something to consider. Everybody's mind works differently, everybody sees things differently, so I just wanted to kind of point that out, that that's another option. Some students might say, oh no, dividing 144 by 2 is super easy, because 14 divided by 2, that's 7, and then 4 divided by 2 is 2. More power to you, right? All right. So now we are going to take the square root of both sides, okay? And I'm going to kind of come up here, okay? And so then we get x equals, and the square root of 72 is just 6 root 2, okay? And if you want to know what all the math is to get from here to here, the square root of 72, you can click right there. I have a video on it of me finding the square root of 72. So that's way 3. So I think to sum everything up, okay, what matters the most to me is that you think about these 3 ways. They're kind of tools in your toolbox, and when you are given a problem, a special right triangle problem, 45, 45, 90, okay, that you think of the many different ways you can approach solving it, okay, because I'm not going to say, you always have to do it this way, you always have to do it that way. I'm going to say do the way that works best for you. Be careful with way 2 because it is memorization, but it can also be super duper fast, especially in the case of something like 12, okay? In the case of 5 root 2, it made it more difficult. Way 1 will always work, okay? Way 1 will always work, and way 3 will always work, and you're not memorizing, except I guess you have to have this formula memorized. In the first one, you have to know the ratio of the sides. But either way, so I guess you can make the argument either way you're memorizing. But I think the big thing here is that you need to know that it's okay. Whatever way you choose, it's going to work. You're doing a great job. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.